All right, you guys, I'm back with an optional lesson today. We are not going to be able to do our rock identification lab this year, and it just breaks my heart because rocks are one of my favorite things to investigate and to look at. And we have lots of really cool rock and mineral kits at school. So hopefully, if you're watching this optional video lesson, maybe it'll inspire you to go out and hunt for some rocks and minerals and see if you can learn a little bit about them. So this is going to be kind of a longer video lesson because I want to tell you everything there is to know about identifying rocks in as short amount of time as possible. And I'll give you a lot of cool resources you can use if you ever want to become a rock hound and go out and identify. So I recently went out on a trip to Arizona in February this year, and it was a rock hunter's dream. There were so many cool rock formations and rocks to see that we just don't have here in Michigan. Michigan was scraped across by glaciers, a few tens of thousands of years ago, and we don't have the same kinds of rocks here as they do out in Arizona. A lot of our rocks are sedimentary and fairly new compared to rocks out west. So what I'm going to do today is I'm going to walk you through how you can identify minerals, which are what make up rocks, and the three main rock types, which you learned about in the rock cycle last week. So rocks and minerals are definitely related. Minerals are a simplified form, and many minerals can make up different rocks. So this is actually a slideshow from an older project that I did before, and I want to take a minute to tell you about the differences between rocks and minerals. So minerals are naturally occurring. They're inorganic solids. They usually have a really defined crystal structure, and some of our precious gems are minerals. And they're made up of really specific elements that can be formed into different compounds. And so the pretty crystals that you see in, like, let's say a granite rock are actually different kinds of minerals. So there are 5 characteristics for minerals, and I highly suggest watching the Mr. Parr video I'm going to show you at the end. It is my favorite Mr. Parr video on minerals. So minerals occur naturally in the crust. They cannot be man-made to be considered a mineral. They're definitely 100% inorganic. So minerals cannot contain any fossils or living materials or once living materials. They're solids. They have a really cool crystal structure or repeating pattern. And if you look more at mineral identification, there are quite a variety of different crystal structures, and they're all at very precise geometric angles. And there's a definite chemical composition. So I'm sure you guys know what salt is. Salt is a pretty common mineral. We know it's a mineral because it qualifies in all 5 of the requirements on the previous slide. So kind of flying through these slides. Scientists actually are finding new minerals every year. The list of known minerals is very long. The textbooks that we use inside Earth actually have a list of minerals and their chemical compositions in the back. There's a lot of minerals that are grouped as silicates. They actually contain 2 elements from the periodic table, silicon and oxygen, and those make up 95% of the Earth's crust. So there's quite a few of them. All right, so let's go through. There are minerals that are considered non-silicates, and they don't contain any of the elements silicon. And there are also minerals considered native elements. We have quite a few of these in Michigan. There are a lot of copper and silver mines in the UP, but diamonds and graphite are included in that as well. So I did link this slideshow in today's agenda if you want to do more with minerals, but I'm going to kind of skip over that for right now. I want to get to the rock online lab that there is available for you today. So now for rocks. All rocks are made up of minerals, and there are more often than not many minerals that make up a rock. And if you can identify the minerals that are present by either the crystal structure or the color, sometimes you can identify a rock just by that. So we have a process of identifying and naming rocks, and a lot of it has to do with the rock cycle. We first of all want to try to figure out if a rock is igneous, metamorphic, or sedimentary. And we use a lot of different methods to help us identify a rock. And really, just looking at it can do most of the identification, but sometimes further identification is needed, and labs can break rocks into little pieces, run them through machines, and do more in-depth chemical analysis. So when we use the word texture in identifying a rock, we're really looking at the look and the feel of the rock's surface. So there are rocks that are completely smooth. Some of them are rough and bumpy as if they're made up of other little rocks. Some look like glass, and some are very, very chalky. Now, some rocks have grains or smaller particles of minerals or other rocks, and sometimes looking at the size of the grain, the shape, and what pattern they're lining up in, if at all, can help us to identify the rock as well. So we usually use the words fine or coarse for grain size. There are lots of different shape terms, and sometimes the grain patterns can be layers, swirling, rows, or random. And then there are some rocks that have no grains at all. A lot of people are familiar with this rock. This is obsidian, sometimes called obsidian glass. This is an igneous rock that forms when magma cools so fast that there isn't time for crystals to grow. So one thing you want to know about minerals is the bigger the crystal, and this applies to rocks too, the bigger the crystal, the longer it took for that rock to form by cooling. So sometimes magma never makes it to the surface as lava, and it can cool deep within the earth over thousands of years. And those big, beautiful crystals come out in the rocks. So notice my background. These are some pretty cool rocks. They remind me of rocks that you might find on the shore of Lake Superior. Those rocks are very, very round and smooth from wave action, but you can definitely see some different textures, some different patterns, some different colors for sure. And this rock right here is most definitely granite. Now, I know you can't look at page 148 to identify these rocks, but there are actually 2 sedimentary, 2 metamorphic, and 2 igneous rocks pictured here. Take a minute and just ask yourself, what do I see in these rocks? Do I see different grains? Are they big? Are they small? Is there any kind of pattern that I notice? At the end of the slideshow, I'll come back to these 6 rocks and I'll tell you what kind they are. All right, so we don't often know what the exact mineral composition is. Sometimes we can do tests on those minerals. There are field tests, like you can streak the mineral, see how hard it is. That'll sometimes help you identify a rock, but more often than not, this is for looking at rocks in labs and under microscopes. So back to our 3 rock types. We have igneous rocks that form when molten rock cools. And remember, that can happen deep within the earth or on the surface as magma comes up as lava. Sedimentary rock forms when particles of other rocks, plant, animal remains, fossils are found in sedimentary rock, are pressed into layers. And metamorphic rock forms by extreme heat and pressure. And this is a lot more pressure than is required to make a sedimentary rock. We're talking deep, deep, deep within the Earth's crust, or chemical reactions that occur deep underground. So let's talk again about the rock cycle one more time, just so you can recall. Igneous rocks form from cooling magma. They can be eroded into sediment. They can be squeezed into metamorphic rock. Sedimentary rock forms from the sediments of any of the 3 rocks. Yes, a sedimentary rock can be regenerated back into a new sedimentary rock. And any of these rocks can be squeezed into metamorphic rock, which over time, if enough heat and pressure occurs, it's just going to get pushed back down into the crust, into the magma chambers that are in the mantle. So we talked about these yesterday. Well, it's actually been a couple days ago. Back to our rocks. Okay, so I see some texture in this rock and this rock for sure, as well as this one. These are a little harder to see, the texture or the grain size. And this is our obsidian glass, which is very, very smooth. no texture, no crystals at all. So this is going to be an igneous rock. This is granite. Each different color represents a different mineral. And some granites have very, very big crystals and some have small. There are even some granite that has a combination of big and small minerals, and those are pretty desirable for countertops. Now, this rock right here actually is not igneous. I made a mistake on that. It looks a lot like granite, but here's the clue. Here's the giveaway that it's not an igneous rock. You should notice right off the bat that there's some stripes. And basically when an igneous rock gets squeezed over time, it becomes this metamorphic rock called gneiss. So that would be the parent rock, and this would be the child rock. And we just use it sometimes to help understand how one rock turns into another. This is a sedimentary rock. This is definitely bits and pieces of other rock that has been eroded. So this is sometimes they call it pudding stone, but it's a rock we call conglomerate. And this is also a sedimentary rock, but you can see that the grain sizes are very, very difficult to see. This could be either sandstone or it could be limestone too. Very, very tiny pieces that are maybe not visible to the naked eye. So you might be looking at this going, wait a second, this kind of looks like this, little tiny pieces. The clue here is that it looks like it could be chipped off into layers. And this is going to be another example of a metamorphic rock. So this is slate, and slate is actually a result of a tremendous amount of heat and pressure on clay particles. So you can't really see the grains anyways. It would be very small to begin with. And slate used to be used for chalkboards. So we have igneous, metamorphic, sedimentary, metamorphic, and our obsidian is going to be igneous. So how do you identify rocks? Well, igneous rocks are usually pretty easy to identify because they have crystals. Some have big crystals, some have small crystals, some have a combination, and so we use these words to describe them. Extrusive igneous rocks, cool on the Earth's surface and intrusive within the Earth's surface. And porphyritic is just a fancy word for a mixture of large and small grains. There are light and dark colored igneous rocks based on what kind of minerals are in there. And here are 4 very common igneous rocks. We've seen obsidian. I'm sure you're familiar with granite. Basalt's used all the time for gravel driveways. And pumice is a very light rock. It actually floats. People use it all the time for scrubbing their feet. So sedimentary rocks are formed by erosion, deposition, compaction, cementation. And so we have a lot of different sedimentary rocks out there. Some are just other rock pieces stuck together. That's the word clastic. Some are formed from decomposing dead plants and animals deposited over layers. And some are from minerals that have been dissolved. So imagine an ocean from ancient times evaporates and all of the salt and minerals are left behind. Those layers from within the ocean bed can form limestone and rock salt, and that would be considered a sedimentary rock. Coal is a sedimentary rock. And limestone may be a rock that you look a little closer at because some of our monuments are made out of limestone, and it's highly reactive with acid rain. All right, so we've talked about igneous, we've talked about sedimentary rocks. Let's talk about metamorphic rocks, and then we'll be done. So there are some metamorphic rocks that are very clearly layered, or they look like they split into sheets. So the slate I showed you earlier, there's another one called schist and gneiss. And I found a ton of mica schist when I was out in Arizona, and it was the most beautiful, sparkly, silver-looking rock. I mean, if you didn't know anything about rocks, you probably would have thought you grabbed a piece of silver. It was just beautiful. And it was very, very much layered, or sometimes we call it foliated. Now, the metamorphic rocks that aren't layered, they're really tough to identify. They're non-foliated, they don't have layers, but they are formed from heat and pressure. Marble and quartzite are examples of this type of rock. Now, these are 2 more rocks that are oftentimes used in monuments, and they're actually child rocks of the parent rock, limestone. So they're also very subject to acid rain. Quartzite often forms from sandstone, and it's very closely resembling quartz mineral. So, I should go back to this. If you happen to choose the Taj Mahal for your Save the Monument or World structure, it's actually made out of white marble, and it's currently falling apart because of weathering and erosion. And it is definitely in danger and needing fixed. So here's some more pictures for you. This is going to be marble. See, there's no layers here. Here's a nice picture of a foliated rock. That's some slate. That's the gneiss. And this is quartzite. This is just a neat little chart that shows you some common metamorphic rocks and what they come from. And that's the end of the slideshow. So here's what you might want to use if you're really into rock hunting. Here's a little chart you can use to document some observed characteristics. You can figure out if it's sedimentary, igneous, or metamorphic, and what rock name it is. I found this cool dichotomous key online. It's kind of like a yes or no identification sheet. It doesn't identify a ton of rocks, but I know there's like way more resources out there. All right. This online lab is not bad. It's the best we can do without actually having our box of rocks in front of us. You can grab a rock from the box and you can try to figure out what type of rock it is. You can do all sorts of tests on it. Just make sure if you click on this link that you enable your Flash player. So, nothing to do for an assignment. This is just for fun. I know it was kind of a long video lesson, but I really love collecting rocks, and this was something I really wanted to share with you. And if you guys are interested, you can, if you have rocks at home, bring them to the Zoom meeting on Thursday. Maybe I'll bring a couple of the rocks that I collected from Arizona, and we can just have a cool discussion about rocks. So, this was optional. I hope you learned something. Maybe you'll go outside and hunt for some rocks. And we'll get started on the week 3 lessons right after this. So we'll see you soon.